we are going to be learning the unit circle. And technically, we don't need the unit circle anymore because we have calculators. However, the unit circle will help you understand trig in ways that it would just be very, very, well, actually impossible to understand if you didn't have trig, if you didn't have a unit circle. So, what do I mean when I say unit circle? I mean, we call the radius of the circle 1. Just like when we defined radians, it doesn't matter how big your circle is, just call the radius 1, and then all circles will spit out the same values. Okay? So I have this circle, and I divide it into 24 equal rotations, which means I put 5 marks inside each quadrant. And then I sort of just ignore the first and last point in every quadrant. And the reason we ignore those is those numbers aren't very nice. And back when you probably were in 9th grade, you learned a couple of reference triangles. So you learned the 45, 45, 90 triangle, and you learned the 60, 30, 90 triangle. And when you did that, the legs of this triangle were 1, and then the hypotenuse of that triangle was root 2. And then the short side of this triangle was a 1, and the hypotenuse was 2, which meant that the other leg was root 3. Okay? So we're going to use both of those triangles, but we want the hypotenuse to be 1, not root 2 or 2. So to transform this triangle is easy. I just divide everything by 2. And then this becomes a 1. And then I divide everything here by root 2. And the hypotenuse becomes 1, but the rules of simplifying square roots say that we're supposed to multiply this by root 2 over root 2, and that ends up being root 2 over 2. Root 2 over 2. So, how big are these angles in degrees? So you're going to fill this out. So this angle right here represents 1/24th of the entire circle. So the entire circle is 360 degrees. If I divide that by 24, then I get 15. But that's not one of the angles I care about. The first angle I care about is this one, that rotation right there. And so that is 15 plus 15 is 30 degrees. So write that on the inside of your circle. Oh. What would the next mark be? 45. And the next mark? 60. And then we skip 75. But this one is going to be 90. Okay. And the next mark, we skip that one. But what would this mark be? Well, we skipped the 105. So this would be 120. And then 135. And then 150. And we skip 165 to 180. And then we skip 195. And we get 205, 220, and 235. Oh, wait, no. It's 210. Yeah. Those aren't the numbers I wanted. So 210, 225, and 240. Don't forget the 270. And then 300, 315, 330, and then this one would be 360. Okay. How big is each notch in radians? Well, there are 24 notches, and the entire circle is 2 pi. So if I take 2 and divide it by 24, I get 1/12. So this mark right here, don't write this down, is pi over 12. And every mark after that is 1/12 bigger. So what is this mark going to be? 2 pi over 12, which simplifies to be pi over 6. And the next mark would be 3 pi over 12, which is pi over 4. And the next mark, so that would be 1, 2, 3, 4 pi over 12, which simplifies to be pi over 3. And then we skip 5/12. The next one would be 6/12, also known as pi over 2. And we skip 7 over 12. The next one is 8 over 12, which simplifies to be 2 pi over 3. And then 9 pi over 12 becomes 3 pi over 4. And then 10 over 12, 5 pi over 6. And we skip 11/12. And the next one is 12 over 12, also known as pi. Okay. And then we skip 13 over 12 and go on to 14 over 12, which is 7 pi over 6. Am I going too fast? Okay, and then 15 pi over 12 is 5 pi over 4. 16 pi over 12 becomes 4 pi over 3. Okay, and then we skip 17. 18 pi over 12 is 3 pi over 2. And then we skip 19. 20 pi over 12 is 5 pi over 3. 21 pi over 12, 7 pi over 4. 22 pi over 12 is 11 pi over 6. And then we skip 23, and the last one is 24, which is just 2 pi. Okay, make sure everybody has all those written down. Don't mess up. All right, is everybody good? Okay. So what is the coordinate of this point? So I'm going to draw a triangle, and you don't really have room to draw triangles. So I'm going to draw this triangle here. And because this is a unit circle, I'm going to call the hypotenuse 1. So this angle right here is a 30-degree angle. So what is the x comma y of that point? How far is it from here to here? Well, that matches up with this triangle there. So this length matches up with that length. So the x value is root 3 over 2. How high is that point? 1/2. Okay. Now let's remember SOHCAHTOA. So what is the sine of 30 degrees? The cool thing about trig is the sine of 30 degrees is independent of the size of the triangle. It doesn't matter how big your triangle is. Every single right triangle where theta is 30 will yield the same O over H ratio for that 30-degree angle. So let's look over here. If I had this triangle, and this was root 3 over 2, and this was 1/2, and this was 1, and this was 30 degrees, what is the sine of 30? Well, sine is O over H. But something cool happens when H is 1. It's just the opposite divided by 1, which is equal to the opposite. And that's why we want a unit circle. If the H is 1, then the 1 stops mattering for sine, cosine, and tangent. Okay? So it turns out that the sine of theta is the opposite side as long as H equals 1. Right? So what is the sine of 30? Well, it's 1/2 over 1. But do I really need to divide by 1? No, it's just 1/2. And 1/2 happens to be the y value. So we can if we can figure out what all those points are, then we have a whole bunch of answers to sine, cosine, and tangents of specific angles. Okay? So that's where we're headed. What about this triangle? If that is a 45-degree angle, what is the x value? Well, I look at my 45-degree triangle, this one right here. Root 2 over 2 is the x. What is the y value? It's also root 2 over 2. All right. Now I draw my 60-degree angle, my 60-degree triangle. What is the x value there? 1/2. Okay, and what is the y value? Root 3 over 2. Okay. Now what about the 90-degree angle? What are the coordinates of that point? 0, 1. The radius of the circle is 1, so that point is just 0, 1, which means the 0-degree angle has the coordinates 1, 0. All right. Watch what happens when I try to do 120 degrees. So let's switch colors. So I want a 120-degree angle. So I'm going to rotate to here, and I'm going to draw this side. Can I create a right triangle where one of the angles is 120? No, you can't. However, we can create what we have referred to before as a reference angle. So I'm going to build the triangle here. How big is the reference angle? It's going to be 60. Right? It's essentially the same angle that we created there. It's just in quadrant 2. Well, is the angle negative? No. But what about the coordinates? So what is the x value of that point in quadrant 2? Well, it's going to be the same as this, except the x will be negative. So negative 1/2 root 3 over 2. Okay, what about the next point? Negative root 2 over 2, comma, root 2 over 2. Okay, what about the next point? Negative root 3 over 2, comma, 1/2. All right, what about the next point? Negative 1, 0. You guys are getting the hang of this. This one? Negative root 3 over 2 is the x. And the y? Negative 1/2, because I'm below the x-axis. Okay, the next one? Negative root 2 over 2 and negative root 2 over 2. Okay, the next one? Negative 1/2, comma, negative root 3 over 2. And the next one? 0, negative 1. And the next one? 1/2 on the x and negative root 3 over 2 on the y. Okay, the next point? Root 2 over 2, negative root 2 over 2. And the next one? Root 3 over 2 and negative 1/2. That is the unit circle. Okay? So, what is the cosine of 240 degrees? Well, can we build a right triangle with a 240 inside it? No, impossible. It doesn't work. Okay? So, what we do instead is we rotate until we get to 240, and then we draw this triangle. The x value is negative 1 over 2, the y value is root 3 over 2, and the hypotenuse is 1. And cosine is a over h. But h is 1, so cosine is just the a value. Which one of these is the a value? So here's my angle. Which one is adjacent? Negative 1/2. So, in the unit circle, cosine of theta is always the adjacent side. And if you look at all of these triangles, so there's a triangle, there's a triangle, there's a triangle, and there's a triangle, which one of those sides is always A? The x coordinate. So the cosine of theta is the x value, and the sine of theta is the y value every time. So watch this. What is the cosine of 240? Let's make sure I'm in degrees. I'm not. So the cosine of 240 is negative 1/2, which is what we got from the triangle. Okay. What is the sine of 120? 0.86. So 120, we look at the y value, root 3 over 2. So the square root of 3 over 2, or sorry, square root of 3 divided by 2 is 0.86. Okay. All right, what about the cosine of 7 pi over 4? So we go to 7 pi over 4, which is right here. Cosine is the x value, root 2 over 2. Okay. What about the sine of, let's do 480 degrees? Well, 480 is too big to fit on the circle. So what should we do with it? Subtract 360. So 480 minus 360 is 120. So we just go to 120 and look at the y value, and the answer is root 3 over 2. Okay? What about the cosine of negative 2 pi over 3? Which quadrant is negative 2 pi over 3 in? It's in quadrant 3. Where does it land? In the same place as, so 2 pi over 3 is there. So negative 2 pi over 3 would be here. And what is the cosine of that angle? Negative 1/2. Okay? Does that make sense? What about tangent? Oh, that was not what I wanted to do. I just want to get rid of these. So tangent is O over A. Tangent of theta is O over A. But we just learned that the sine of theta is O, and the cosine of theta is A. So tangent is actually equal to sine over cosine, or also known as y over x. Which is kind of weird. Every single tangent calculation could be completed even if your tangent button on your calculator was broken. If you had a sine button and a cosine button, and I asked you to perform a tangent, all you have to do is take the sine of the angle and divide it by the cosine of the angle, and you'll get the same one. In fact, you only need one trig button. So we have sine, cosine, tangent. There are three others: secant, cosecant, and cotangent. You can do every calculation using a single button. Just like if all you had was the number 1 on your calculator, you could perform every single calculation out there. If you want a 0, then you do 1 minus 1. If you want a 10, then you do 1 plus 1 plus 1 plus 1 plus 1 plus 1. Right? If you want to multiply 3 times 4, then you do 1 plus 1 plus 1 times 1 plus 1 plus 1 plus 1. Okay? So all of the trig functions are interwoven together. All right, so what is the tangent of, let's say, 0 degrees? So I go to 0, and I take the y value, which is 0, and divide it by the x value, which is 1. So the tangent of 0 is 0. Okay? What is the tangent of 225? Well, I take the y value, negative root 2 over 2, and divide it by the x value, negative root 2 over 2, which is going to give me positive 1. Okay? What about the tangent of pi over 6? This is a little bit harder. So pi over 6, so we do 1 over 2 divided by root 3 over 2. How do we divide two fractions? Invert the bottom, 2 over root 3. Well, the 2's cancel, and I get 1 over root 3, but I'm not allowed to leave it like that. So you times it by root 3 over root 3, and I get root 3 over 3. Okay. What about the tangent of negative 4 pi over 3? Where is negative 4 pi over 3 going to land? It's going to be right there. Right? So 4 pi over 3 would be all the way to there. So negative 4 pi over 3 would be all the way to there. So I take the y value, root 3 over 2, and I divide it by the x value, negative 1/2. Invert multiply, negative 2 over 1. The 2's cancel. and I get negative root 3 over 1. So the tangent of negative 4 pi over 3 is negative root 3. Okay. So on the back, all you're going to be doing is calculating the values from the unit circle. Now it's going to be a huge pain if you have to flip back and forth. So I'm just going to put a unit circle up on the screen. Okay.